Hi guys, this is Ms. Kissinger and welcome to section 6.2, Properties of Parallelograms. What we're going to do is figure out more properties for just the parallelogram, which is one of our types of quadrilaterals, and then we're going to use those properties to find angles and side measures. Now, we know that both pairs of opposite sides are parallel, which I already have marked. These are the things that we have already learned so far. Now we have four more properties that we need to learn. The first property that we need to learn is that opposite sides are congruent. So that means that this side is congruent to this side, and this side is congruent to this side. Simple enough. Anytime we have a parallelogram, this is true. Now, the other thing that we need to know is that same side angles are supplementary. Now, if two angles are supplementary, I hope you remember that that means they add up to 180 degrees. Now, the next thing we need to know, actually let's mark it up here on our picture first. Same side angles are supplementary, so that means that this angle is supplementary to this angle, and this angle is supplementary to this angle, and vice versa. Anytime you have anything that is same side, so these two angles add up to 180, these two add up to 180, and it keeps going all the way around the parallelogram. Okay, next thing we need to know is we need to know that opposite angles are congruent. So we have opposite angles are congruent. We kind of already have that marked. We know that this angle is congruent to this one, and this angle is congruent to this one. Now, when we say opposite in geometry, we mean across from. So the angles that are across from each other are congruent. And the last thing we need to know is that our diagonals bisect each other. So that means if I were to put in some diagonals going from one corner to the other corner, like this, then I know that this piece is congruent to this piece, and this piece is congruent to this piece. Now remember, the word bisect means cut in half. So that means that where they connect, that means it's cutting the diagonal in half. Now this only works for a parallelogram. If it's not a parallelogram, diagonals don't mean anything necessarily. We just know in a parallelogram that the diagonals bisect each other. Okay, moving on. The next thing we need to know is that consecutive angles are angles of a polygon that share a side. So that means if I were to look at this, consecutive angles are angles that share a side. So let's pick this as my side right here. The two angles that share this side are angle E, and angle F. So angle E and angle F are consecutive angles. The next thing is angle F and angle A are consecutive angles. Now, I could have written it, angle A is consecutive to angle F. It doesn't matter the order as long as you write it. So the other two that we have are angle E and angle K are consecutive, and angle A and angle K are also consecutive. Now, let's use this information that we've learned in order to solve a simple problem. So, moving down, we want to find the measure of angle M in parallelogram MARY. Now, I knew that it was parallelogram because we made this little parallelogram symbol before we wrote the letters. Now, when we're writing the letters, it does not matter which direction you go, but you need to go all the way around. You cannot cut across when you're naming a parallelogram, just like when we did triangles and everything else. So, if we're finding the measure of angle M, that means we're going to be finding this measure. Now, the thing that I learned on the page before this is that same side angles are supplementary. So I can say that the measure of angle M plus the measure of angle Y is equal to 180 degrees. And I already know what the measure of angle Y is. So I can say the measure of angle M plus 112 degrees is equal to 180 degrees. Now I do some simple algebra, minus 112 on both sides. So now I have the measure of angle M is equal to 68 degrees. Okay, now we're going to move on and do some more things with the properties that we've learned. Okay, so first thing we're going to do is find the value of x in parallelogram FISH. Then find IS and FH. We want to find the length. Notice that there's not a line over the top of here, so we are finding segment length. First thing we need to do is find x. Now, our very first property that I told you today was that opposite sides are congruent. So that means I know that this side is congruent to this side, which means I can say 3x minus 15 is equal to 2x plus 3. Now I can add 15 to both sides, just like a regular problem. So then I get 3x equals 2x plus 18. And then I minus 2x from both sides. So then I get x is equal to 18. Now this is awesome, but we haven't quite finished the problem yet. I haven't finished the problem because it says then find IS and FH. So I need to figure out what the actual value or what the length of this segment is. So all I'm going to do is take my 3x minus 15, and I am going to plug in my x value, which was 18. So I have 3 times 18 minus 15, and this is IS. And we have 3 times 18, which is 54. So I have 54 minus 15. So then I have 54 minus 15, which is 39. Now, if we did our problem correctly, then this should be the same thing. So FH should be equal to 2 times 18 plus 3. 2 times 18 is 36. So we have 36 plus 3, which equals 39, which magically is the same. Alright, now let's move to the next problem. We are going to find the value of y in parallelogram STIX. Now, we know that opposite angles of a parallelogram are congruent. Again, we figured that out on a couple pages ahead. We figured that out right here. Opposite angles are congruent. It's one of our properties. So, if we know that the opposite angles are congruent, then that means I know that this angle is the same as this angle, which means I can set up a simple equation that puts 3y plus 37 equal to 6y plus 4. So now I'm going to take minus 3y from both sides. So then I have 37 equals 3y plus 4. And I'm going to subtract 4 from both sides. So then I have, then I have 33 is equal to 3y. Divide both sides by 3. And 11 is equal to y. So I know that my value for y is equal to 11. Okay, using more algebra, we are going to use a system of equations. A system of equations, it means it's more than one equation to find the values of x and y in parallelogram WORM. Then we're going to find WS, SR, OS, and SM. So the first thing we need to do is remember what it means when we have diagonals. Remember, diagonals bisect each other, so that means that I don't know why that keeps happening. That means that this is congruent to this, and this side is congruent to this side. Okay, so that means I can say that y equals x plus 1, because these two are congruent. I can also say that 3y minus 7 is equal to 2x. Now I have a system of equations. Now, we learned to solve a system of equations either using substitution or elimination. In this case, since I already have a y equals, I'm just going to substitute that piece in here for y. So now I have 3 times x plus 1 minus 7 equals 2x. Now, the reason that this is in parentheses is because my y value is equal to this whole piece. So I can't just write x plus 1 because then that's going to be wrong. Now, I need to distribute. So I have 3x plus 3 minus 7 is equal to 2x. Now I can combine like terms. So I have 3x, and then 3 minus 7 is negative 4 equals 2x. Then I can subtract 3x from both sides. So I get negative 4, don't forget that this was minus, negative 4 equals x, or negative x, sorry, because 2 minus 3 is negative 1. Divide both sides by negative 1. So I get 4 is equal to x. So I know my x value. Now I need to figure out my y value. And how I'm going to do this is I am going to plug it back in here. So I have y is equal to x plus 1. My x is 4. So I have y equals 4 plus 1 and y equals 5. So now I have my new values. It says then find WS, SR, OS, and SM. So WS is 3y minus 7. So I have WS is equal to 3y minus 7. My y is equal to 5. So I have 3 times 5 minus 7. 3 times 5 is 15. Minus 7 is 8. So WS is equal to 8. Now I need to do SR. SR is equal to 2 times x, and x is 4, so we have 2 times 4, which equals 8, and that makes total sense because this segment should be congruent to this segment. Now, I need OS is equal to x plus 1, x being 4, so we have 4 plus 1 equals 5, and my SM is just equal to y, which is equal to 5, which makes sense because, again, these two should be congruent to each other. Okay, so far I hope this is going well. If it's not, pause, write a question down so that you have something to ask me tomorrow in class. Now, here's the next thing. If 3 or more blank cut off congruent segments on one transversal, then they cut off congruent segments on every transversal. What this should say is if 3 or more parallel lines cut off congruent segments on one transversal, then they cut off congruent segments on every transversal, meaning that AC is congruent to CE and BD should be congruent to DF. Now, these are my parallel lines. My horizontal lines are my parallel lines. And these two lines are my transversals. So I know anytime a parallel line is cut by a transversal, 3 or more parallel lines are cut by a transversal, then the two segments are congruent. So, if we're looking at this picture, it says use the figure below. The horizontal lines are parallel. So that means I know that this is congruent to this, which is marked. So if they're congruent and this is 4, then this one also has to be 4. I also know that this line is congruent to this line. And if this is 3.5, then this one automatically has to be 3.5. So now we can answer our questions. It says find each length. The first one, is XZ. XZ is really easy because we already figured it out, which is 4. The next one is ZV. So Z to V is 4 plus 4. 4 plus 4, which equals 8. Now we have WU. WU, which we already found was 3.5. And UY, which is this whole piece, which is going to be this segment plus this segment. So 3.5 plus 3.5 is equal to 7. All right, this video is a little bit faster than the other ones, so I hope you enjoy your next 5 minutes of free time. I will see you tomorrow in class ready to do the assignment.